Hello and welcome to Data Vidyalaya. Today we'll start with Introduction to Python, and this will be our first video in the Python series. So the first thing that comes to mind when learning Python is where to write the Python code. So we can write the Python code in various environments, which is VS Code, which is a popular text editor. There are some IDEs that we can use. There is idle, which comes with the Python. There is Jupyter Notebook, and we can even write the code on Notepad. So these are the several methods that we can employ to write the Python code. But as our journey will include mostly data science related stuff, so we'll be preferring Jupyter Notebook. And to avoid the setup that is required for setting up the Jupyter Notebook locally, we'll prefer what is called as Google Colab and write our code in Google Colab, which can be easily shared and also requires very minimal or no setup. So let's go ahead to Google Colab and let's see how to write code there. So for this, this is Google Colab, and as you can see, this is the welcome screen for the Google Colab. The URL for Google Colab is colab.research.google.com, where we can write our Python code. I have already created a notebook which says Introduction to Python, and any Python notebook has extension .ipynb. So this stands for IPython notebook. Let's go ahead and see how the interface for the notebook is. So I've already opened the notebook in another tab, and this is how the notebook looks like. So I'll start with very basics of this notebook, and as we go ahead in this course, we'll go in more depth. There are two types of cells that can be added. So cell is a row that can be edited in Jupyter Notebook. For example, this is a text cell while this is a code cell. How do you add a text cell? To add a text cell, I click the plus text icon, and the cell which I am on, below that a new cell is added. I can add any text here, and the format for, let's say, a big heading is hash plus, let's say, intro to Python. So this is how the text cell works. For the code cell, we'll click the code icon, the plus code icon, and I can see that the code cell is added below the cell where currently I was. So this is how the interface of the Python notebook looks like. I'll just delete this cell, and let us go ahead and start with our session. So before starting, we'll make sure that we connect to an environment. This is a runtime, so I'll explain what are the different runtime that Google Colab offers. But for now, we'll connect to the runtime, and as we can see, we get connected once it is connected. So this connects to a Python kernel. After that, so for running a particular cell, so as this is a text cell, it will not run, but for running any cell, we will click Shift plus Enter. So once I click Shift plus Enter, this cell is executed and I go to the next cell. Before delving into how to write Python code, let's understand what Python is and why Python is important. So Python is a interpreted programming language which is easy to write. It is very similar to what we write in plain English. It is obviously a programming language, and it powers mostly all of the AI ML applications that we currently see. So it is a industry standard for many data science and related applications. Why Python should be used is a major question before starting to learn Python. So let me explain some points. These are only some of the points that I think are important for learners to know before starting Python. So the first point is Python reads like English. So the syntax that Python uses is very clean and it is intuitive, making it the easiest language that a beginner can start to learn. Next we have the point where we can see that Python is versatile powerhouse. What it means is it can do almost any kind of coding stuff that it needs to, from building websites and mostly all of the AI that we currently see, automating the boring tasks by writing scripts, and also web scraping is one of the use cases that Python has. Next we have the point where we see that Python has a massive community. So it has a very big community with millions of users, and if you run into some bug, there will surely be someone who has solved that bug and it can help you. That's not a very big issue nowadays because we have generative AI, but still it kind of reassures a learner that there is somebody to help if something goes wrong. Next, we can see that you need less coding and more doing. So you can often accomplish several tasks with 5 lines in Python that may need 20 or plus lines in C++ or Java. This is very important for beginners because coding languages or programming languages, you can see they are languages as the languages we speak. So if a learner learns a easy language, it is very easy for him to start playing with that language and developing his or own applications. But if the language that he learns in the very beginning is hard, he may fall into the syntax and he may struggle with the syntax a lot, and rather than doing some creative work or doing some great projects with that language, he is often trapped into the syntax. So this is why Python is most preferred when starting with programming. So this is why we'll learn Python. And the last but not the least is the high demand, which is Python is most in demand language today. This is because, as we see, AI and ML have become the buzzwords of today, and so there is a very high need for Python developers, data scientists, data analysts, machine learning engineers, data engineers, and all these job roles require Python as the primary language. So you can see that Python is a very useful language and it's very industry relevant too. So let's start with the Python, and let's start with the first lecture and the first step towards learning Python. So let me go ahead, and before starting any language, we have what is called as the hello world ritual. Hello world ritual means we have to just print the word hello world before starting to learn any programming language. This has become a ritual in most of the languages, and so let's start with printing hello world. So to print anything in Python, we just write print. So as we can see, this is as simple as we write in English. So let me print hello world. So print, and then there will be these double quotes which define strings in Python. So we'll go into that a bit later. For now, I'll just print hello world. And for running the cell, as I told you already, we'll just hit shift plus enter. So as we can see, hello world is printed. So this is how Python allows you to write code in a very simple language or syntax. Let us go ahead and understand what are variables and data types. So variables are like memory locations where particular data is stored. So let's say I have some variable x and I assign it a value 5. So I can use that variable x which contains that value 5 in my further program. This is like like what we see in mathematics. This is sort of similar concept where a variable is nothing but it stores some kind of information for us. In Python, we don't need to tell the computer what type of data are you storing. Python is smart enough to figure it out that what data type the particular variable is as you assign it a value. This is often called as a dynamically typed language because of this sole reason. So a dynamically typed language is nothing but a language in which the variables are assigned a value without specifying the data type of the variable, and this works. So this has both advantages and disadvantages. We'll go into this part a bit later, but for now, let's see how we define variables in Python and how are values assigned to them. So let's say I want to define variable x, and that variable x I need to give value 5. So this is how I assign x the value 5, which is x is equal to 5. And let's say I want to assign some variable y a value 10. So this is how I assign it. After that, I'll move forward. Let's say I want to assign some variable, let's say b, as intro to Python. These are the 3 variables I need to define, and all of these are defined in this way. For running this code, again I hit shift enter. So this is how simple it is to define variables in Python. Let's move ahead and understand the data types that are supported in Python. So we have this 4 primary data types that are very important. So there is one more data type which is complex numbers. We'll take a look at it next time. But for now, let's understand this primary 4, which are the most used data types in Python, and understand how are they defined. So first one is string. String is what stores a plain text, and it is always wrapped in quotes. So that quotes can be single or double quotes, any works. After that, we have integers. So integers are whole numbers which are either positive or negative. Next we have float. So float is a data type which stores numbers which are floating point or decimal point. So numbers which include decimal point are often known as float. And last we have boolean. Booleans are like logic gates which store either true or false values. So when I say a data type, a variable as data type boolean, it means it can either be true or false. We'll have a look at each of this now. So let's say I want to define a string s as hello Python. This is how I define this string. So we saw earlier how to define a string. I have purposefully used another which is a single quote here. So just to mention that any type of quotes work in Python. So you can give either a double quote or a single quote. After that, we'll go with what a float looks like. So let's say I define f as a float and give it a value 19.99. I move ahead and I give a value boolean, b a boolean value which is a true one, and let's say I give something a which is false. We also have x and y defined earlier. So it is a very good use of Python notebook. We can separate our code and it becomes very easy to understand that what its code means, because we can add text about that code. So as we can see that I have defined some text in the cell which is above this code cell, and it describes what my code does in the below cell. So this is how the notebooks are very useful when learning data science. So I'll hit shift enter. Now let's move ahead and add one more cell in order to show you that how do I check the type of the data type of the variable. For that I have a keyword which is type, type. I write type and in that I'll write variable name. So let's say I want to check the type of the variable s. Now it is a very useful functionality in the Python notebooks that we do not need to write print in many cases, and the notebook automatically prints the code, the output of the code that we write in it. So I'll just write type s and I'll hit shift enter. As we can see, the type of the type of the variable s is correctly identified as the string. Let us move forward, and now to print many things, I'll just separate them by comma, and this is only allowed in Python notebooks. If we write a Python script, we have to add a print statement. We'll take a look at it. After that, I'll just write type of, let's say, x, type of a, type of b. Now let's shift enter. So as we can see, the type of s is a string, x is integer, and a and b are both boolean. So this is how you can check the data types of various variables in your code. So this was about the variables and data types. Now let's move forward and understand what operators are. So for understanding the operators, we have different kind of operators, and first we'll have a look at the arithmetic operators. So arithmetic operators are operators that define arithmetic operations. We'll have a look at arithmetic operators one by one now. So plus defines addition, minus defines subtraction, the star symbol defines multiplication, slash defines division, double slash defines floor division, percentage defines the modulo operator, and double star defines the exponential operator. So the first four, which are addition, subtraction, multiplication, and division, are very intuitive in Python, and this can be easily recognized. The next three are somewhat high in level, and we'll understand them. So double slash means floor division. So what a floor division does is, whenever you divide two numbers, and let's say I get an output 3.5. So floor division will return the nearest integer which is less than or equal to that particular number. So let's say I have 3.5, it will return me 3. What if I have 3.9? Again it will return 3, because I have to return the number which is less than or equal to that number. It will not round it to 4, but it will return 3. Let's have a look at how floor division works. For that, let me write 3, 39. Let's say first I do, so I can directly add two numbers in Python as is. So this is how I add 39 and 10. So this is like what you do in calculator. It's very easy. Now I'll just divide these two numbers and the output should be 3.9. This is what we expect, and this is what we get. Let's now do a floor division and let's check the output. So we get 3. The answer without floor division was 3.9, but when we use floor division, the answer is 3 because it returns the number which is less than equal to that particular number and which is nearest to it. So this is what the floor division does. Let's now move ahead and see what the modulo operator does. So the modulo operator returns the remainder of the division. So let us have a look at what 39 modulo 10 will give. So you can think about this and I'll give the answer now. So 39 modulo 10 will return 9 because 9 is the remainder in this case. So this is what the modulo operator does. And let's now move ahead and see the third operator in this series of 3 operators, which is the exponential operator. So what does the exponential operator do? Let's say I want to do 2 cube. So for that I'll write the star 2 times. I'll add 3. So I'll get 8. This is what the exponential operator does. So for reference purposes, let us quickly write all the operators one by one. So 2 plus 3 will be 5. Let me go ahead and add some code cells. Okay, 2 plus 3 will be 5. 3 minus 2 will be 1. 3 by 2 will be 1.5. 3 floor division 2 will be 1. 3 modulo 2 should be 1. Okay. Then we have, let's say 3 square, which should be 9. So these are all the operators in action and you can have a look at them. After that, we have comparison operators. So comparison operators, what they do, they compare two numbers. So let's start with the comparison operator. The first is equal to. Now in normal mathematics, we have, if we have to compare two numbers, we just write a single equal to. But the issue is in Python, we have already used one equal to when we want to assign a particular variable a value. So if we use the same thing while comparing, it would be a confusion for that particular language to understand what the user is trying to say. So to avoid this sort of confusion, equal to, whenever we want to check whether a particular value is equal to another value, we use double equal to. If we have to check not equal to, we'll add exclamation mark and then equal to. Greater than will be same, less than will be same. Greater than equal to will be written like this, where the equal to will follow the greater than sign, and similarly the equal to will follow the less than sign in less than or equal to. Let's have a look at each of them now. Let's say I want to check whether 3 equals to 2. It is obviously false. Let me add some code text. Okay. Okay. Let us now say I want to compare two variables a. Let's say a is 5 and b is 3, and I have to check whether a equal to b. So this is false as expected, which is easy. Now let us check a not equal to b. This should return true, which is also correct. Let us check whether a is greater than equal to b. Sorry, a is greater than b or not. This is true. If we add a equal to, what do you think should be the answer? So when we write this particular symbol, it means that we are checking that a is greater than or equal to. So in any one condition, this condition should become true, and as expected, it will return true. So remember this is important. Let's say I write a less than b, it will return false. Let's say I write a less than equal to b, this will also return false. So this is how we compare two numbers. Now let us move ahead and try to compare two strings. So for comparing two strings, I'll define S1 as ABC and S2 as ABCD. Okay, I'll hit shift enter. So let us check S1 is equal to S2. This should obviously return false because these two are not same. We can see this this here itself. Now let me add some more code cells first. Now we'll continue to this I'll bring up. So to bring any cell up, we'll just hover over that cell and we'll get this, which is the move up option. We can also use the shortcut, which is Control M and K. So I'll use the shortcut and I'll move this cell up. So this is where I want the cell to be, and it is there. Okay, now we have we have checked whether S1 is equal to S2. So S1 not equal to S2, this would be true. The most important things to check are greater than or less than. So let me write S1 greater than S2. Is this correct? This gives me false. Now, can you think about the reason why this returns false? And once you think about that, think about how should the greater than operator work in Python in order to compare two strings. So you think about that and I'll give the answer now. Let's say I define S1 is equal to ABC and I define some S3 as C, B, C. Okay. So as we can see, only the first character in the string differs, and alphabetically if you compare, the first character of S3 is ahead than the first character of S1. So if I do S1 greater than S3, it should return false. Oh, this error is there because we did not run this cell, and so we get name S3 is not defined. So we'll first run this cell and I'll try again to run this particular cell. So we'll get false. Okay, so S3 greater than S1, this should return true. So as you can see that the two strings are compared alphabetically and character by character. Let's say the first character becomes same, the second character is same, and the third character changes. Now in this case, the third character of S1 is alphabetically less than what the third character in S3 is. So again, this should return true and we get the answer as 2. So remember, while comparing any two strings with either greater than or less than signs, it compares the logical operator greater than or less than, compares the string alphabetically and character by character. If the initial characters are same, it will move forward and check the next characters. And if all characters are same, then the string becomes equal. So the two strings become equal. So this is what the logical operators look like when we use them with strings. Okay. So this is what we had in the comparison. I said logical operators, sorry. It should be comparison operators. So this is what the comparison operators look when we use them with strings and integers. Now let us move forward and look at the third category of operators, which are the logical operators. So for logical operators, we have three operators which are AND, OR and NOT. So when are these two operators used? So these three operators used. These three operators are used when we want to compare two booleans. So how will we compare two booleans? Let's say I now define A as true and B as false. So as you can see, I had already used A and B earlier in this particular notebook, but as Python is an interpreted programming language, it runs line by line. So this is not relevant in the notebook very much, but you should remember the fact that Python is an interpreted language, so it runs the code line by line. And this is very important when we write code in the form of Python script. So we run the whole script at a time, and if I define the variables again below the original definition, the variables that are defined below will override the values, override the variables that were defined earlier. So this same thing applies in notebooks too, where even if we don't run the notebook all at once, whatever variables we define after the original definition override the previous definitions. So this you have to remember, and it is not a very hard thing to grasp. So it is very easy. Let's say I have A equal to true and B equal to false, and I want to use logical operators with A and B. I'll add some code cells again. So let's say these cells were not used. So I want to delete these cells. I can click this delete button here or use the shortcut which is Control MD, and it will delete the cells. So this is how you delete cells in Python notebook. I'll add some more cells here. I'll need those. Don't need, we'll delete them. Okay. So to compare two booleans, we use the AND, OR and NOT operators. So what is an AND operator? In simple English, what do you mean when you say AND? I want a chocolate and an ice cream. I want a chocolate and an ice cream. So this means that I want both the chocolate and the ice cream. And if I say that I want the chocolate or the ice cream, it means that I need any one of them. So this translates to programming language as well and to logic as well. So let's say A is true and we have B is equal to false. What do you think will be result of A and B? Think about this and I'll tell the answer now. So A and B will return the answer as false because A and operator needs both of them to be either true or false. So if A is equal to true and B is equal to true, then only the final result will be true. If both are false, which is A is false and B is false, then the final result will be false. In any other case where A true, B false, or A is false, B is true, the final result will be false. This is easy to understand once you get the concept. So this is what a AND operator looks like. A OR operator, on other hand, checks whether I get any one of the two values. So let me check whether A or B is true or false. So I'll write A or B. What do you think the answer will be? So the answer is true. This is because it needs any one of them to be true. Let's say I change this to true and B also true. So A and B will now change to true. A or B will now change to A or B will stay true. So this is how this works. Let me change it to false and false to cover all the cases. So now A and B will again become false. What do you think A or B will be? So A or B means either A or B, both of which is false. So this becomes false. It is again easy to understand. Take some minute or so to understand this concept, as we'll be using this very frequently later on as we go in this course. So this is what the two operators, which is and or, look like. Now let us move forward and use the not operator. So not operator is easy to understand. It just reverses the value of the variable. Let's say I have A is equal to false now, and I write not A. It returns true. That means it has reversed the value of A and returned the result. This is what not does with the Boolean variables. So this is how the logical operators work with the Boolean variables. I'll just delete these cells because we don't need them anymore. So this is what the operators look like in Python. These are what the operators look like in Python, which are, to summarize, which are divided into three parts, which is arithmetic operator, comparison operators, and logical operators. So these three type of operators are available for you in Python. I have experimented with them for you. You can go ahead and play with these operators and be familiar with them and be thorough with these operators, because these are the fundamental building blocks of Python and will be used very frequently in writing the Python code. So this was what I had for today. So I think the video is long to cover each and everything that I planned, but I'll keep this short in order to help beginners to grasp each and every concept. I want every learner to be thorough with what I teach in this video and to understand each and every concept that I have given in this video. For those who are not beginners, it may seem that this video is too easy for them, but stay tuned. As we will move forward, we'll increase the complexity one by one, and I would like to assure you that we will be touching each and every aspect of Python. We'll delve into libraries, which are the core functionality of Python. The libraries like NumPy, Pandas, Matplotlib, Seaborn, etc. These are the fundamental libraries, and then we'll also move to the machine learning theory and machine learning practicals with scikit-learn, and again after that we'll move to our deep learning journey. So this journey will be a long journey, and I want you all to stay tuned with me and follow this journey, and this will help you a lot in your data science journey. So let us wrap this video up here for now and meet again in the second video. Till then, practice all the things that I have given in this video, be thorough with all the concepts, and let us meet in the next video. Thank you very much for watching, and wish you all the best for your Python journey.